Today we are looking at functions and their graphs. A relation is any pairing of numbers. So a relation is input values, output values. Basically, a list of ordered pairs, any graph, anything like that is called a relation. The domain is the inputs. You're familiar with those as the x values. The range is the outputs. You're familiar with those as the y values. A function is a specific type of relation where there's only one output for each input. There's only one y for each x. Okay, this is called a mapping diagram. Basically, in number one has the points -2, 6. It's a little bit shifted, but do you see how -2 is connected to 6? -1 is connected to 5, so we have the point -1, 5. 0 is connected to 7, and 0 is connected to 8. In order for it to be a function, we can only have one y for each x. So 0 has the y value 7. 0 also has the y value of 8. Is that okay? One y value for every x value. This x value of 0, how many y values does it have? There's 2 y values for that one x value. That is not okay, so that is not a function. Honestly, this is easiest to see if you have a list of ordered pairs, because what you're looking for is no repeated x values. If you have a repeated x value, that means there's 2 y's for that one x value. Okay, take a look at number 2. We have the coordinates 5, 1, 9, 7, 11, 7, and 12, 0. You have done this before. Okay, honestly, you're looking at the y value, or at the x values. Are there any repeated x values? There's no repeated x values, so this one is a function. So the trick here is, are there repeated x values? If there's repeated x values, it is not a function. If there are not repeated x values, it is a function. During your assignment, you will be asked to make a mapping diagram like this. Basically, you look at your ordered pairs, you put the x values in the input, you put the y values in the output, and then you draw arrows to connect the ordered pairs. Ordered pairs in the form xy is another way to represent a relation. So here are 4 ordered pairs. I would like you to plot those points. Remember, ordered pairs, you move side to side first, then up and down. You have to walk to the elevator before you go up and down in the elevator. I like to use this style of grid because we can put the origin wherever we want to. Technically, I should make you draw in the x and the y axis every single time. But do you really want to do that? No. So let's just make an agreement. If we don't draw those axes in, we're going to assume that 0, 0 is in the center of this picture. If you want to move your origin, say you wanted to put it like this, and you want 0, 0 to be right there, then draw in your axes. So if you don't draw in the axes, we will all just assume that 0, 0 is right there in the middle. Okay, let's plot the first one together. The point 2, 5 is 2 to the right from the origin and 5 up. Right there is the point 2, 5. On your own, pause the video, plot the next 3 points. Yes, this relation is a function because there are no repeated x values. What if we add the ordered pair 1, 5? Why is that one not a function? Because now we have a repeated x value of 1. And on the graph, look what happens when you have a repeated x value. There's a vertical line that touches 2 points. Do you remember something called the vertical line test? If a vertical line touches more than 1 point, that means there's a repeated x value and it's not a function. So a relation is a function only if no vertical lines will touch more than 1 point. So if I put an infinite number of vertical lines in here, every single vertical line is only going to touch 1 point. That one is a function. This middle one, it looks kind of funny, but even in the steepest part, if you zoom in and put a vertical line in there, that vertical line is still only touching 1 point, so that one is a function. What do you think about that third picture? A vertical line touches 2 points, that is not a function. All right, so on your own, graph these points. It's just another way of showing you ordered pairs. Instead of actual ordered pairs, the x value is on top in the table, the y value is on the bottom. So this point is -5, -6. So take a moment and graph this relation. Okay, once we plot these points, is this a function? Yes, this is a function. You can see in the table that there are no repeated x values, and you can see in the graph that vertical lines would only touch 1 point at a time. All right. A linear function is a function that can be written in the form y equals mx plus b. Basically, plain, ordinary x. Not x squared, not x to the third, not x on the bottom of a fraction, just plain, ordinary, run-of-the-mill x. So we need to decide, are these linear functions? Then evaluate for the given value of x. And this brings back in function notation. F of x doesn't mean multiply f times x. It just means this thing is a function. It uses x. We're going to call it f. So f of x is just a label. It means the same thing as y equals. So number 6, is it a linear function? Is it plain ordinary x? Yeah, it's absolute value of x, but absolute value is technically linear. So yes, this is linear. So I'm going to write linear. F of -6 means take -6 and plug it in. So you would do absolute value of -6 minus 5. What is the absolute value of -6? And 6 minus 5 is 1. Technically, you should write f of -6 equals 1. Math people really, really love function notation, because it shows you the input, -6, and the output, 1. From this label, I can say the ordered pair -6, 1 is on this graph. So it just gives you more information than y equals. If all this said was y equals 1, okay, great. Where'd that 1 come from? All right, number 7. Is it a linear function? No. Technically, you're supposed to still plug in the 4, but do you just want to skip that if it's not linear? Okay, if it is not a linear function, let's skip plugging in f of 4. How do we know it's not a linear function? That's a great question. What is there in that equation? The x squared. X squared is not plain x, so it's not linear. That would make one of those parabolas. Number 8, is it linear? Yes, this one is linear because it's a plain ordinary x. Let's plug in -7. 2 times -7 plus 3. What is 2 times -7? -14. And -14 plus 3 is -11. Technically, you should write f of -7 equals -11, because then we can see the input and the output.